Greetings and welcome to Session 3, Understanding Note Intervals. My name is Jerry and I'd like to begin by reminding you from Session 1 that the primary goal of this learning series, entitled How Chords Are Formed and Used for Absolute Beginners, is obviously to get you forming chords as soon as possible. As you can see in our map, this will remind us where we have been, where we are, and where we are going. The title of this session may perhaps seem uneventful, unnecessary, or even boring, but in reality, it is a very important session since all music is based upon understanding the, quote, arrangements of note intervals, which is the source for creating differences between every chord. When all is said and done, the common denominator separating every different chord type and their unique sounds is understanding how note intervals are used. Technically speaking, note intervals provide the mathematical roadmap for, quote, organizing the elements of chord forming that you will see as we go through this series. And as you move forward in this learning journey, I hope you will begin to appreciate the significance of how intervals between notes affect how we go about forming any chord. So what we hear when we listen to our favorite songs are, quote, sounds or tones of notes being played at specific distances apart, called note intervals. Some of these note interval sequences give us melodic sounds, more commonly called melodies, and are created by playing individual notes one after another in some tonal riff and/or rhythmic pattern. Typically, melodies are those musical phrases that we hear and hum to our favorite songs that become the signature hook expressions that we tend to remember and repeat. Melodies are considered unison sounds where each note is played individually in some repeatable musical phrase or in some combination of notes and pitches at some tempo or rhythm. For example, we likely recognize the unison notes to Mary Had a Little Lamb. Most everybody knows this melody instantly. A pretty simple melody we probably heard as a youngster and still remember today. Now here's another example you may or may not know depending upon your generation of music interest. It is a different sort of melody that you might recognize instantly as the iconic two-note bass introduction to the song My Girl from the 60s. It sounds like this. These are the notes I'm playing, but an octave lower. But back in the day, simply hearing and playing those two notes were all it took for an audience to pack the dance floor immediately. Again, so simple, but it has become a huge success and melodic hook to the introduction by the Temptations. And again, the song is My Girl, and these are only two examples of thousands of unison melodies. So the next time you're driving your car and singing along to your favorite song, remember you are likely singing melodies, that is, unison notes. And as you might guess, there are other sounds we hear that are created by playing a collection of notes simultaneously, giving us harmonic tones, otherwise known as harmonies. Harmonies are created by playing multiple notes organized around predefined note intervals, such as what a choir of vocalists sing or chords being played on a guitar or piano. Harmonies are created by instruments such as pianos, keyboards, guitars, and voices where multiple notes can be played or sung at the same time. Harmonies help fill in the musical background of songs to support their melodies and lyrics. In essence, harmonies are what we call chords. For example, if we accompany the melody notes of Mary Had a Little Lamb with the harmonic chord notes, we get a much more full and rich sound. you can hear this arrangement coming to full life with more energy, movement, and emotion. It is this total mixture of note interval, melodies, and harmonies which gives us the signature footprint or riff of most songs. Now let's hear what happens when we add the chord and their note intervals to My Girl. And this time it's the introductory little melodies that I'm playing. So it's got that second melody line that begins and carries the song throughout. So this is the song My Girl by the Temptations back in the 60s. So you have the harmony notes played simultaneously, which then represents a chord. And then you've got up in the upper hand, you've got the melody line. That is a particular pentatonic scale, which we'll learn more about scales later, but those are the notes, and that's played together. That's part of why that song is so iconic, that it has several great parts in it that make it become instantly recognizable. That actually was a song that was originally recorded and released on December the 21st, 1964. So this combined, these are the notes and the note intervals, which are part of the magic as we listen to music, whether we're a listener or a musician and or both. So that's part of the significance of note intervals. And note intervals can be distinguished by careful listening. Here's a quick example, not to learn the chords per se, but to hear the harmonics at work. Here are 3 different chords created by starting on different notes, but see if you can hear the same harmonic sound they all 3 have in common. Listen closely. Here's a C chord. Here's a D chord. And then here's an E chord. It doesn't matter what the chords are, but the harmonics are the same. And the reason they're the same is because the note intervals between each of the notes of each of those chords are the same. So here's the first chord, a C chord. If I counted the intervals, I could always count the start note as 0, and then I can go 1, 2, 3, 4, and then 5, 6, 7. So I'm at 0, 4, 7. Those are the harmonics of a major chord in C. Now, if I wanted to play a major chord and the chord being D, my start note is the D note. And if I count 1, 2, 3, 4, and then on to 7, 5, 6, 7, the D major chord is made the same harmonics. It's just a higher pitch than the C chord. So here's C, here's D. And if we went up one more to say an E, we're going to start on the E note. 1, 2, 3, 4, and then 5, 6, 7. So an E chord, an E major chord is made with these 3, and that's because the note intervals are the same, whether we're playing a C chord, C major chord, D major chord, or an E major chord. Though the note intervals are what makes them very same in harmonics, the same harmonic sound, even though you may not be able to pick that up as an absolute beginner. Just keep that in mind as we move forward reaching there. So it's because the note intervals of each chord are the same, despite the fact that they are different named chords, because they each start the chord on a different note. C note for a C chord, D note for a D chord, and an E note for an E chord. But don't worry if you can't make this hearing distinction yet as an absolute beginner, because with more seat time at the piano, you will begin to hear these harmonics. For now, it's just a heads up for something to listen for in the future. And now let's begin exploring the mechanics of note intervals. Measuring the intervals or distances between notes are expressed using a variety of terms that we will soon see. But I believe the best term to use for counting note interval distances is the term semitone. A semitone is the distance count of one. That's one note interval between any and every note and its very next neighboring note. So, for example, if we wanted to know how many note intervals are between a C note and an E flat note, then the semitone count would be 3. So when we're semitone counting, we always count the start note. In this example, the start note is C. We always count the start note as 0. And in the case of finding out the E flat between the interval between the C note and the E flat note, we would call this 0. Then this is 1, 2, 3. So the note interval distance between a C note and the E flat note is 3. 1, 2, 3. And that's the way semitone counting works. If we wanted to know what the interval is between a D note and let's say an F sharp note, then we would start with D note being 0, and then that would be 1, 2, 3, 4. So that interval distance is 4 semitones between those two sets. So you can go all the way up and down any way that you want to do that. I'll go back to the C and the E flat example because interestingly, when any distance interval in semitones is 3 between any two notes, that's also has another name called a minor third interval. And we'll learn later that the minor third interval and the major third interval are used in combinations to create all kinds of chords. And we'll see that down the road, but that's why I'm pointing it out. A minor third interval, if we wanted to know a minor third interval from the E note, then we would go E note is 0 and then 1, 2, 3. So those are the minor third intervals there. So we can go anywhere. If we wanted to start on an F sharp, count up 1, 2, 3. That is the same interval and the harmonics sound of those. So that will be an interesting term that we will see more and more as we get closer to actually understanding how chords are formed. And so just notice here, semitones are counted the same way whether we count up or down the keyboard. So if I wanted to go what is the minor third interval going down, we would call this 0 and then 1, 2, 3. And then those are different notes, but those are the same interval in that, and it's a minor third interval. So whether we're going up or whether we're counting down, the semitone counts remain the same. And a semitone count does not care whether its next neighboring note is a white or black note. So we can forget all the colors as we've talked about in a chromatic octave where we contain all the notes. So it's my position, if you use semitone as your only unit of note interval measurement, which again I highly recommend, it will keep things simple and consistent, especially when we get into forming chord notes. And for me, as a fine furniture maker, I use semitones to count distances between notes, just like I would use a tape measure to measure distances in inches on a piece of wood. So before I get away, I also want to make mention of another thing that I hear a lot of musicians talk about, and it's still beyond me. They talk about and make a big deal out of the distance between an E note and an F note. They're like, oh, well, there's just whatever. Well, just understand between the E note and the F note is one semitone distance. And they also make a big deal between the B and the C note. And so physically, the reason they're making a big deal about it is because there's no black note in between these, as these notes have black notes and in this set of 3 black notes. But from a tonal standpoint, there is the same distance between here and here as there is between here and here, or here and down. So it's just one semitone of distance between E and F, and B and C as there are between any other two neighboring notes up or down. So it's really not a big deal. And what that means then is if we do a chromatic octave like we looked at, and then back to the C note again, those 12 notes are all of equal temperament. That's part of a music theory term called equal temperament, meaning they are all tonally one semitone distance apart, up or down. So don't be misled into thinking there's some significance about the distance between an E and an F or a B and a C note, because there is the same distance between here to here as there is between here to here, there to there. Any neighboring note's just one. So don't let that get confusing, but it seems like many musicians make a big deal out of that. And for me, there is no big deal. But to be transparent for you and to have an awareness for whatever reasons, semitone counting, as I've just expressed here, semitone counting of note intervals seems to be very underutilized. And what I mean by underutilized is that most musicians I know do not use semitones to count note intervals. And for me, that's not a good thing, because as we continue, you'll see how important the term semitone is and how we use that to form chords, and we can do it accurately every time. So in fact, I think that semitone counting of note intervals is so important that I have a dedicated session 6 to it. So be watching. For now, let's continue with understanding other terms used to describe note intervals. Now here's where confusion begins, so stay with me. The following are other terms and abbreviations that identify note intervals that, unfortunately, you must wade through to decipher which ones are need to know, nice to know, or unnecessary to know. Without question, I believe the following terms add unnecessary confusion and use needless repetitive counting process to describe the same thing. But they are used over and over, so you will need some familiarity because you'll see most people use these terms. These terms include tone. This term is abbreviated with a capital T and equals a note interval distance of 2 semitones. That's its definition. It seems this term originated to distinguish the different tones from one white note to the next white note. And it does. But remember mathematically that a tone is equal to 2 semitones of distance, whether counting between white or black notes. So why not just say 2 semitones rather than using the term tone and avoid the confusion of converting back to numbers? To further complicate the vocabulary, there is a second often used term that is also equal to 2 semitones, and it's called a whole step. It's capitalized with a capital W, a totally duplicative and unnecessary term. Again, why not just go back to the basics and use semitone count numbers rather than using either the terms tone or whole step? It just seems that using semitone count numbers is a much simpler and more accurate count in reducing confusion and arriving at the same numerical answer quicker. No wonder absolute beginners stay confused. The last useless note interval counting term, I guess because the terms tone and whole step were already being used, was created by someone who felt the need for even another term known as half step, abbreviated with a lowercase h, and is used as a 1 count, which ironically is the same count as simply 1 semitone. So now we're full circle and back to a count of 1. How simple can it be? Yet over time these terms have added so much confusion. And I've often wondered why any single key on a keyboard would ever be called a, quote, half step, since there are not any half keys on a keyboard. So in reality, any note is simply 1 semitone interval apart from its neighboring note, as counted in any direction. We just need to stop making simple stuff complicated. So now, do you see how unnecessary all these terms are and why they add to the maze of confusion to an absolute beginner? Personally, having to mentally fumble around recalculating simple math just to identify note interval distances doesn't make sense. Just use the semitone note interval distance counts of 1 and you'll be accurate every time. But because these terms are still prevalent, having been used for decades, maybe centuries, the reality is that it would be hard to change and reduce their frequency of use. So at least later, when you see the capital letter T or the capital letter W for tone and semitone and the lowercase h for half step note interval counts, you'll at least know what they are referring to. And in future sessions, I will continue to show you how valuable semitones and semitone counting can be in forming chords. Now let me introduce 3 of 4 different but related note interval naming classifications, of which I'll quickly cover as they are primarily used by composers, songwriters, music theory educators, and/or vocalists, not so much by musicians per se. They are note interval names, scale degree names, and solfege names. As an absolute beginning musician, you will not likely need to know them in depth, but at least you can know of their existence and have a general notion of what they are about when you see them. Should the need arise later in your musical journey, you may wish to revisit these. The 4th note interval language, known as note position numbers, are so important that I will cover them as a standalone topic in session 4, the very next session coming up. But until then, let's look at these 3 classifications individually. The first of these 3 note interval naming classifications is known as note interval names. These, quote, names use both letters and numbers for each of the 12 notes in a chromatic octave and are assigned in sequence beginning with P1 on any starting notes you choose and continues in order up the keyboard. To better see these note interval names and their sequence, let's list them in a chart as you see here. Their names are P1, then a lowercase m2, an uppercase M2, lowercase m3, uppercase m3, a P4, D5, P5, M6, lowercase, uppercase M6, lowercase M7, uppercase M7, and then a P8, where P is the term perfect, M, lowercase m is for minor, uppercase M is for major, D is for diminished. Now we'll get into more of that later. For now, we're just introducing this classification system. But while we're here, make a point to yourself that there are 2 of these that are most often used describing note interval names, especially when discussing how chords are formed, and that is the M3, and that is also called and known as the minor third note interval, and the uppercase M3, which is called and spoken as the major third note interval. Those 2 you will hear and see used many, many times as we get into forming chords. So that will be coming up in upcoming sessions. Lastly, as you might imagine, some combinations of, quote, note intervals do not sound very pleasing, as you will later experience for yourself on the keyboard. Most notably, any 2 notes played simultaneously that reside next to one another, like a neighboring C and a C sharp note, if you play those together, sound very unpleasing, or what we call dissonant. So those are unpleasing, dissonant intervals, and because of that, the music world has actually declared some of the more common and good sounding note intervals, and that would include just the P1, the perfect first interval, which is actually not an interval, it's just a single note played by itself. But then when you add and you talk about a perfect fourth intervals, which is a 5 semitone count up from the whatever start note that you want to start on, that's considered a perfect fourth interval from its start note. A perfect fifth interval from its start note is a 7 semitone count, and notice now I'm using the counts of semitones. And then the perfect 8 interval is what we kind of talked about before in the other sessions, is the octave note. It's actually a 12 semitone count, because when we do semitone counting, we're having to count every note, the white and black notes, not just the whites. But you can decide later for yourself if you agree with these isn't good sounding note intervals, and we'll do more and more as we begin forming chords, which is coming up here in these sessions. So pretty much that's it for what I would just want to say now for one of those classifications called note interval names. A second of the 3 note interval naming classifications is known as scale degree names. These particular note interval names include both numbers and one-word descriptors, but of only the 8 perfect and major note interval names just covered. Let's use the previous chart and add the scale degree numbers and scale degree names as shown to get a good picture of their note interval alignments and relationships. So don't let this chart unnerve you here. We're just adding a couple of more things to what we just covered. Although the scale degree names aren't used much by the average amateur musician, it is somewhat common to hear the following related terms. The first degree we really talk about and call is tonic, more often referred to as the root or start note. I'm not really consistent with using those terms. I may use tonic in one conversation, and later in the conversation I may use root or start note. But tonic, root, or start note are all referring to whatever note that you're going to start with. The 5th degree interval also is known from a scale degree name as the dominant interval. It's the 5th degree, and then the 8th degree is what we have been calling the term octave. So that's all standard and stays the same. And at least you can see how these relationships line up with one another. Remember, scale degree numbers and names are just another language for describing note intervals, depending on who the party is that might be using those. Nothing particularly noteworthy. And certainly as an amateur, you don't have to know or memorize any of these. Just know that these things exist. A third of 3 note interval naming classifications in this session is known as solfege names, invented in the 18th century in Italy. This particular note interval system uses syllables that were created for vocalists in their practice of duplicating note pitches. The pitches of each syllable are sung relative to some starting note and represent the note intervals of the 7 notes of the major scale plus the octave 8th note. These are the same syllables you may have heard sung by vocalists practicing their music scale notes. Do, re, mi, fa, sol, la, ti, do. Or you may remember hearing them sung in the colorful Do, Re, Mi song from the Sound of Music movie years ago. For now, just realize that these solfege names are, in essence, another unique type of language used for describing note intervals. As you can see in the chart that we started, we've just added the very bottom one so you can see their alignment to the other scale degree and note interval names. So notice that the solfege fall on the perfect and the major note interval names, as well as the scale degree numbers there. So just know that this exists, and maybe just a tad of history there where it came from, and you've probably heard someone do the do, re, mi, fa, sol, la, ti, do, which is what they're doing. In summary, the purpose of this session, Understanding Note Intervals, was to introduce you to the foundation and fundamentals of what allows us to hear what we hear. Whether playing single-note melodies or playing multiple-note harmonies, the resulting sounds we hear are created by particular note interval combinations between notes. So in music, note intervals mean everything. And we also learned a few terms that can be used to describe how note intervals can be counted, most notably semitone counting, which we will continue to use in future sessions, and I will cover even in more great detail in session 5. And we also saw 3 naming languages for classifying note intervals that you will occasionally see that you may or may not use depending upon whether your primary focus is on songwriting, composing, or musicianship, not that you can't be all 3. And now, a look ahead. As mentioned in the beginning of this session, A fourth note interval naming classification exists known as note position numbers, and they are so important that I dedicate the next session, session number 4, to completely explaining them, since they are a critical pathway in understanding how every chord is named and formed. As always, thank you for your time and attention. Please subscribe if you found this session helpful in your music theory journey as an absolute beginner.